Grade 12s, we're starting a new unit, exponential and logarithmic functions. And again, it starts nice and sweet with stuff we already know. So we're going to look at the rules of powers so that we can simplify expressions. So just as a recall, a power has a base and an exponent, and the whole thing is called the power. Base, exponent, the whole thing is called a power. So our rules that we know for powers only are useful for expressions that have the same base. So for instance, if we have a product of two powers, 3 squared times 3 to the 5th, our rule is only applied because both of those powers have the same base of 3. So where the rule comes from is that expression means 3 times 3 times 3 to the 5th would be 3 times 3 times 3 times 3 times 3, which would give us 7 3s equals 3 to the 7. So our rule would be if you have the same base, you would add the exponents. If it makes more sense to you to just write in English, whatever floats your boat. All right, quotient rule. If you have two powers that are being divided and they have the same base, we get our rule from 4 times 4 times 4. How many did I have? 7 of them. Divided by 4 times 4. You know you can divide out like factors, and we are left with 4 to the 5th. Our rule, if we have the same base when dividing, is to keep the base, subtract the exponents. You know some of the rest of these as well. Power of a power. If you had 2 cubed to the power of 4, that means 2 cubed times 2 cubed times 2 cubed times 2 cubed, which would be 2 to the 12th if you were to expand that whole thing. Our rule is keep the base, multiply the exponents. Power of a product. If you have two things being multiplied together, I'm going to use 3x just to make a point. And you raise it to an exponent, that exponent affects everything in the brackets in front of it, so it will affect both the 3 and the x. 3x cubed means 3x times 3x times 3x. So you have 3 cubed and x cubed. Anything, let's do ab to the m, is a to the m, b to the m. And if you forget anything, like the example I have of 3x, you would miss the number. Every part gets raised to that exponent. Power of a quotient, same idea. If you have, let's do 7 over 3 squared, that means 7 over 3 times 7 over 3, which would be 49 over 9. Both the top and the bottom are affected by the exponent. And we would have spent some time proving that to you last year. 0 exponent, this is the wonderful one. Pick any number you want. To the power of 0 is a 1. As an aside, if you have -7 to the 0, you know that that's 1. But if you have -7 to the 0 like that, you have a negative number. And the only thing being affected by the 0 is what's directly in front of it. So it's negative, and 7 to the 0 is 1. Be careful with that. Negative exponent. If you have a negative exponent, something like 3 to the -2. The negative exponent means flip. Actually, I'd like a little more space to do 2 examples. Okay, negative exponent. I don't remember what I had. 3 to the minus 2. The negative exponent means to flip or invert. So we have 1 over 3, and that 2 would affect both the top and the bottom, but 1 squared is always 1. If I do it with a slightly different example, 2/3 to the minus 3 would be flip, and that exponent is going to affect both parts. So we're going to have 3 cubed over 2 cubed. The negative just makes it upside down. So let's write our example here as a fraction. If you have a over b to the negative m, it will flip, and the m will affect the bottom and the top. Rational exponents is the new and more difficult one. A fractional exponent means a root. So if you have 4 to the 1/2, it means the square root of 4. With square roots, we tend not to write the little 2 in there. It's not necessary. But if you have something more difficult, let's go with 125 to the 2/3. The 3 is the root, the bottom of the fraction. So we are looking at the cubed root of 125, and then we're going to use the power of 2 a little later. Cube root of 125 is 5, and then we'll square it. So for our general case, a to the m over n. It's the nth root of a raised to the mth power. Let's do some examples together. Expressed as a power of 4. 4 times 16. 4 itself is the same as 4 to the power of 1. 16 is the same as 4 squared. I can write that as a single power of 4. With multiplication, we would add the exponents. The second one, 4 to the power of 5 divided by 4 squared. Our rule for division is keep the base, subtract the exponents. Done. The third one, I have power of a power. 4 squared to the power of 7. I multiply the exponents. 4 to the 14. Huge. 3x squared. 3x squared is the same as 3x times 3x. It is a power of a product. That square will affect both the 3 and the x. So we end up with 9x squared. 8 to the 4th, x to the 4th could be rewritten in a different form as 8x, all to the power of 4. X to the n, x to the m. Lots of ways of writing multiplication in mathematics. Squished up in brackets means multiply. We have the same base, so my rule for multiplication is keep the base, add the exponents. D, x to the 4th, all to the n, is a power of a power, so we have keep the base, multiply the exponents. E is a little different. We have a product with the same base of x. X to the 4th times x to the n. We keep the base, multiply the, add the exponents. It's different from D. Simplify. I've got quite a mess for a. A to the 15th times a to the 13th times a over a to the 10th times a to the 11th. There's lots of strategies. Mine would be tidy the top, tidy the bottom, and then see what we can do. A to the 15th times a to the 13th times a to the invisible 1. We would keep the base, add the exponents. I get 29. On the bottom, I have multiplication. A to the 10th times a to the 11th, keep the base, add the exponents. Now I have a division. My rule is keep the base, subtract the exponents, and I'm done. For B, 3x squared y to the 4th cubed. Don't forget that that cubed will affect the 3 and the x's and the y's. So I have 3 cubed. X squared cubed multiply the exponents, x to the 6th, y to the 4th cubed, multiply the exponents, is y to the 12th. 3 to the n times 3 to the 4n times 9 to the n minus 1 over 27 to the 2n plus 2 is a little tricky because our rules only apply if we have the same basis. 9 is not the same as 3, nor is 27. So I'm going to change this question to have only base 3. The first two are fine. I know that 9 is the same as 3 squared. So I'm going to replace my 9 with 3 squared. I'm going to put it in brackets. There. It's the same expression, but with a 3. The 27 I can replace with 3 cubed. So all I have done is replace those with their equivalent powers of 3. Now I've got rules if it's the same base. I am going to tidy up 3 to the 4n. I'm going to tidy up that 3 squared to the n minus 1. I see a power of a power, and my rule would be keep the base 3, multiply the exponents, 2n minus 2. That's why I wrote it in brackets, to be very careful about that exponent. On the bottom, same thing. I've got power of a power. Keep the base, multiply the exponent. There we are. On the top, my rule would be keep the base, and I'm multiplying, so I'm going to add all these exponents. I have n plus 4n plus 2n subtract 2. All of my n's would give me 7n, and a subtract 2. On the bottom, 3 to the 6n plus 6. My rule for division is keep the base, subtract the exponents. I have 7n subtract 2. Maybe it's easier if we write it down. 7n subtract 2, take away 6n plus 6 when I have division. Final answer, 3. 7n take away 6n is n. Negative 2 take away 6 is negative 8. Final answer. D. xy squared to the 4th times 2zy cubed minus xy 6. All on the top. Okay, let's do one at a time. The first one, xy squared to the 4th. That 4 affects the x's and the y's. I will get x to the 4th, y, multiply the exponents, 8, times 2zy cubed. That cubed affects everything. So I have 2 cubed, z cubed. Well, that's hard to tell the difference. 2 cubed, z cubed, y cubed, times. I have negative xy to the 6th. If you have a negative times 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 a negative, an even number of times, you will get a positive. So I can ignore that now. That 6 will affect not only the negative, but the x and the y. I will have x to the 6th, y to the 6th. And on the bottom, x squared, y squared, z cubed. I'm going to tidy the top before I do any division. You can probably do it in one step. But we have x's, y's, numbers, and z's. I'm going to put my numbers at the beginning, just old habit. 2 cubed is 8. X to the 4th, x to the 6th being multiplied, I would add the exponents, x to the 10. Y's. I have y to the 8th times y cubed times y 6. We would add the exponents, y to the power of 17. I only have one pile of z's, so z cubed it is, over x squared, y squared, z cubed. When I have division, I keep the base, subtract the exponent, so I'm left with the 8. X to the 10 divided by x squared is x to the 8. Y 17th divided by y squared is y to the 15th. And z cubed divided by z cubed, you can see it's the same thing. You'd be left with 1. Or our rule would be keep the base and subtract the exponents. Z to the 0 is a 1. I don't need to write that down. Negative exponents, here we go. 3 to the minus 4 is the same as, flip, 1 over 3 to the 4th. Technically, there's also a 4 with the 1. 1 over 81. Negative 2 to the negative 3 is the negative exponent means flip, and I have negative 2, my base, to the 3 now. Negative 2 to the power of 3 means negative 2 times negative 2 times negative 2, which is a negative. If you have a negative number to an odd exponent, you will get a negative. And the answer is 8. 2/3 to the negative 4. That's hard to see the way a Smart Notebook writes it, so here we are. A negative exponent means to invert, so we have 3 halves to the positive 4, which is 3 to the 4 over 2 to the 4, which is 81 over 16. This one is only slightly different. It's negative 2/3 to the negative 2. So I have a negative sign. I'm going to rewrite it. I have negative 2/3 to the negative 2. So the negative 2 tells me to flip and make it a positive 2. So I've got 3 over negative 2. That square will affect both the top and the bottom. So I'm going to have 3 squared, and on the bottom I'm going to have negative 2 squared. 3 squared is 9. Negative 2 squared is a positive answer, 4. My final answer is negative 9/4. And here we are with rational exponents. 16 to the 1/2 is, as soon as I see a fraction, it's a root. A half would be the square root, which you don't have to write, of 16 is 4. 32 to the 1/5 is a root of 32, and it is the 5th root. What I am looking for is 5 identical factors that give me 32. Because 2 times 2 times 2 times 2 times 2 is equal to 32, then the 5th root of 32 is 2. 16 to the 3/4. A fractional exponent means I have a root. The bottom of the fraction goes right there, so it's the 4th root of 16 cubed. It doesn't matter if you cube later like I've drawn it, or you cube first and then take the 4th root. Doesn't matter. 4th root of 16 is a 2, and then we're going to cube it, is 8. Find the value of the expression when a equals 3, b equals 4, c equals -2. There are 2 ways to solve this problem. You can substitute first and then simplify, or you can use your rules of simplification first and then substitute. We're going to do it both ways. Okay, method number 1 is to substitute your values. So my expression becomes 3 to the power of 5 times b, which is 4 cubed, times -2 to the power of 4, all over square root of a to the 4th, 3 to the 4th, times b squared, which is 4 squared. Okay, these are some pretty big numbers. I need a calculator probably. 243 times 4 cubed is 64. -2 to the 4th is positive 16 over square root of 81 times 16. All right, calculator it is. 248832. 81 times 16 is 1296. 6912. Okay, now same problem. You're in a desert island and don't have a calculator with you. We could probably get there by simplifying first. So we have a to the 5th, b cubed, c to the 4th, And on the bottom, we have a square root. So that would be the same as a to the fourth b squared to the power of 1/2. Still not going to do anything with the top until I've simplified the bottom a little bit more. If I have power of a power, we multiply the exponents. So a to the fourth to the half, I multiply those exponents and I get 2. b squared to the 1/2, multiply the exponents, you get 1. I can tidy up now by doing division. A to the fifth divided by a squared is a cubed. B cubed divided by b to the first is b squared, and c to the fourth. Now these numbers are still going to be big, but I can manage 3 cubed times b squared times -2 to the fourth. 27 times 16 times 16. 6912, honest. Last 3 questions. 2 to the x equals 64. I don't have any rules for doing anything here unless I have the same base. So I'm going to rewrite these with the same base. If 2 to the x equals 2 to the 6th, then x must be equal to 6. I'm going to do the same for this one. I don't have the same base, but if 3 to the 2x plus 5, and I could rewrite my left side with a base 3, then maybe there's something I could do. 9 is the same as 3 squared to the 2x minus 8. And on the left side, I have power of a power, and I know I can multiply my exponents, so I will have 3 to the 4x minus 16. Since they have the same base, and that's an equality, then those two exponents must be equal to each other. So I can say that 4x minus 16 must be equal to 2x plus 5. And that I know how to solve. I want to get my x's on one side, my numbers on another. So I am going to subtract 2x from both sides. I'm going to add 16 to both sides and divide both sides by 2. Last one. Well, first of all, it's got a multiplication and a power, and oh my, it's a mess. So my first strategy would be to divide both sides by 3. So I would have 5 to the x equals 125. Since I know that 125 could be written as 5 cubed, 5 times 5 is 25, times 5 is 125, then x is equal to 3. Say, we need to practice. Page 61, 1 to 8, 9 to 16, any one of those is fair game.